Okay, you guys, it's a blank slate. No, just kidding. What we're going to be doing is we are going to be completing a full unit circle. But before we do that, I want to go ahead and show you guys the special right triangles again that we took a peek at in the first lesson. So, for instance, this is a 45, 45, 90, not because it's correct, but because I labeled it that way, so just squint your eyes and then it'll be perfect. The 45, 45, 90 had side lengths of x, and the hypotenuse was an x root 2. Then you had a 30, 60, 90, which could also be written as a 60, 30, 90, but that's not a good drawing, so let me redo that. That's a little more accurate. We'll call that good. The reason why I'm writing it both ways, whereas now this is a 60, this is a 30, and that's the 90, because these three triangles make up every single value and every single coordinate in your unit circle. Now, across from the 30 is x, hypotenuse is 2x, and across from the 60 is x times root 3. And then that follows the same thing. They're the same triangle values. I just went ahead and showed it both ways because you will see 30, 45, and 60 degrees in your unit circles. However, so these are for any value of x. We are looking at a unit circle where the radius, which is the hypotenuse, is 1. So we need to go ahead and scale all these down to 1. Oh, how do we do that? Well, I'm going to help you out. I'm going to show you guys how to do it, and then you guys just get to go off of my work. So what we look at is we need to go ahead and make our 45, 45, 90, obviously not a perfect triangle. This needs to have a radius of 1, which means I'm taking this x root 2 and turning it to a 1. I need to find the value of x. So if x root 2 is proportionate to 1, I need to divide by root 2. I get 1 over root 2, which rationalizing is root 2 over 2. That's my x value. Therefore, this side length in the unit circle is root 2 over 2, and this side length is root 2 over 2. So any 545 degree angle is going to have an x value of root 2 over 2 and a y value of root 2 over 2, whether negative or positive. Now we're going to do the same for this 30, 60, 90. The best part is once I figure out one of them, it takes care of the rest. So over here, let's go blue. We are changing this 2x into a 1. So we're going to write it as that proportion again and solve for x to see that stretch factor. So x equals 1/2, which should make sense, you guys, because x is 1/2 of that. So once again, beautiful triangle. Yeah, it's not good, but we're going to take it and we're going to label it. So this is a 1, this is a 1/2, and then we've got x times root 3. So that's 1/2 times root 3, and we just go ahead and do root 3 over 2. Those are identical. Therefore, this 60, 30, 90 with a hypotenuse or a radius of 1. This is the root 3 over 2 across from the 60, and then across from the 30 is the 1/2. So these three triangles that I'm circling right now are built into your unit circle. If you think back the last couple of days, you guys have been doing bits and pieces, but you guys have been relying off the knowledge off of that table. Now we're going to get rid of that table and we're going to put it all inside of a circle. So I'm going to go slow with it on the next slide. However, pause when you need to pause. there are 4 parts to it: degrees, radians, degrees, radians. You've got coordinate pairs, and then labeling the quadrants 1 through 4 with positive and negative. So we're going to get to that next, so make sure you understand this, and we're going to use that knowledge.